Okie dokie. So let's get started. So today it's not going to be lots of video games and stuff, unfortunately. It's going to more be down to the basics. So what we've got here is x is equal to x. Now, what's the point in this? You're probably thinking, yeah, okay, something is equal to itself. And yes, that's a very, very good point. Thing is, I can rewrite this in a number of ways that may not make it so clear. So x minus x equals 0. And we got to that by going x minus x equals x minus x. So we took an x off of both sides, and we just simply decided to simplify this part and not this part. What we can then also do is, skipping from here to here, we can make this look like anything. So I can square both sides, and then x squared equals x squared. I could add 3 to this, and then we end up getting x squared plus 3 equals x squared plus 3. All of this is still correct. I can do whatever I like as long as I keep it the same on both sides, and this applies with numbers. So let's say we make x equal to 4. So that means that 4 equals 4. So then if we look at the x squared equals x squared, 4 squared is in fact going to equal 4 squared, which is 16 equals 16, and it still works. And again, with x squared plus 3 equals x squared plus 3, so we throw in 4, we have 4 squared plus 3 equals 4 squared plus 3, which is 16 plus 3 equals 16 plus 3, which equals 19 equals 19. And that is all in fact correct. And so, yeah, we have to cover this right at the beginning so that you understand all of this works as long as you're doing the same thing to both sides of the equation. And as you saw up here with x minus x equals 0, we can still do the same thing to both sides of the equation, but the two sides can still look different. So now we're going to move into actually solving something. So x minus 1 is equal to x plus 2. Now here's the first trick, as it were. We want to keep all the like terms together. So x is a like term. If we had y, that would be its own term. If we had z, that would be its own term, so on and so forth. But the point that a lot of people forget is that numbers are their own set of like terms. So on each side of this equation, which we'll refer to as left-hand side, or LHS, and right-hand side, or RHS, we want to set it up so that on the left-hand side, we've just got x's, and on the right-hand side, we've just got numbers. And I've just noticed something. See if you guys realize before I show you, but this equation is actually going to fall apart and not seem correct, because it's not. So we go x minus 1 equals x plus 2. So let's try and move all of the numbers first. So in order to get rid of this 1 here, we need to add 1, because negative 1 plus 1 equals 0. Make sense? So now we have x minus 1 plus 1 equals x plus 2 plus 1, which that then simplified down goes x is equal to x plus 3. Now this is where the whole thing falls to pieces, because how is it possible for a single number to be equivalent to itself added to something? The only way that this could even possibly work is if x equals infinity, which is basically just a number so large that we don't really care about anything else. And so, as soon as we get to this point, we can go, oh, that doesn't really work then, does it? Because the next step would be x minus x equals x minus x plus 3, which then ends up giving us that 0 is equal to 3, which is not correct. So that straight through the equals means not equal to. So we'll do an equation that does work, shall we? I think so. Yes. So now we've got this one. So again, we want to do those like terms. So we've got, in this case, 3x plus 5 equals 2x plus 3. So again, on the left-hand side, or LHS, we want to get all of the x terms, and on the right-hand side, or RHS, we want to get all of the numbers. So first we'll deal with the numbers. So we want to go 3x plus 5, and we want to get rid of that 5 on this side and move it over to the other side. So to cancel out a positive 5, we subtract 5. So that's going to be 2x plus 3, and then we have to do the same thing again, subtract 5. So simplifying that, we end up getting 3x is equal to 2x minus 2, because 3 minus 5 is negative 2. So now we want to move the 2x over to the 3x side. So we end up getting 3x, and I'm just going to leave that as an empty space for now, 2x. So to negate the 2x, we need to subtract 2x, and then we've still got the minus 2. And so we then simplify that. Well, we have to do the same on both sides, so now we have to go minus 2x over here. So simplifying that down, we end up getting x is equal to negative 2. And that there is an answer, and it therefore makes the x mean something. And we can even check this by plugging that negative 2 back in. So we end up going 3, negative 2, because that's where an x was, plus 5 equals 2, negative 2, plus 3. Now when we simplify this, this should come out that both sides are equal, like when I had the x is equal to x. So we have negative 6 plus 5 equals negative 4 plus 3. And so negative 6 plus 5 is going to be negative 1. And negative 4 plus 3 is also going to be negative 1. Therefore, this is in fact correct. X is equal to negative 2. So, let's move on to the next one. Now here, we've got what's not, no longer a linear equation. So, if we were thinking about the one we had before, on a graph, you'd be getting a line that goes like that. Now, I'm actually going to do that in a different color. So, yeah, you end up getting a line that goes like that. Now that is a linear equation. And it's called linear because x is not to the power of anything. X is just multiplied by other numbers. You can technically sort of look at it as, so x, let's use the 3x, what was it, 3x plus 5, so 3x plus 5, and let's just say that equals to y, because then it's an equation, because we have the x and the y axes. So we can actually write this as 3x to the power of 1, because anything to the power of 1 is just itself. And so that gives us that linear equation. If we want to write it in fancy terms to generalize, if we go y equals mx, and we'll call this a plus c, if a is greater than 1, actually no, sorry, if a equals 1, and this is kind of going into programming type language, which is, I mean, it does the job. If a equals 1, then equation is linear. If a equals 2, equation is quadratic. So on and so forth, and it goes like quadratic, then cubic, then I think it's quartic, and so on and so forth, and it just keeps getting bigger and bigger, and the words keep getting stranger and stranger. And that's just for ones with a power. Obviously, if a and x were to switch, so if we had a to the x, that becomes an exponential. And there's various other forms of equation that we'll have a look at later on. But this equation here, the x squared plus 4x plus 4 equals 0, is a quadratic, so it kind of goes like that kind of thing. And then on the other side, also like that. So let's try and rearrange this and figure out what x is equal to. Now the first thing to do with any quadratic is factorize it down into so two sets of brackets, so that you basically have two linear equations multiplied by each other. So in this case it's not too bad because it's all square numbers. So it ends up being x plus 2 all squared equals 0. And we can check this by expanding this out, which is taking it to x plus 2, bracket, x plus 2, which we then break up to x, bracket, x plus 2, plus 2, bracket, x plus 2. And so then we multiply each thing by itself. So x times x is x squared, and then x times 2 is 2x, and then 2 times x is 2x, and then 2 times 2 is 4, which then gets simplified down to x squared plus 4x plus 4. And all of these equal 0. The nice thing with equaling 0, you multiply 0 by anything and it will remain 0. So we can basically do what we like in regards to multiplication, division, powers, roots, all that kind of thing, and the 0 will remain 0. If we add or subtract, then we have to take that into account, but we aren't doing that at the moment. So, if this were more complicated, what we can use is what's called the quadratic equation. This is a handy one to remember, and I believe it is it's been a while. Yes, b squared plus minus the square root. Nope, that's wrong. I'm going to check this just to make sure that I get this right, because there's not much point in teaching you if I'm getting it wrong. So we go to quadratic equation. Quadratic formula is what I'm looking for. Yep, there we are. So x is equal to negative b plus minus square root b squared minus 4ac, all over 2a. So, having that, we have to figure out what a, b, and c are. So we had y equals mx to the a plus c over here. So what we can do is we can go y equals, now the way they represent it is ax squared plus bx plus c. And that a is whatever number is in front of x, which if there is no number there, it's equal to 1, because 1 times something, there's no point in writing the 1. Then the b, that's whatever's in front of just the x by itself, and then the c is the number at the end of it all. So in this case, our a is equal to 1, our b is equal to 4, and our c is also equal to 4. So we can plug this in, and we can go, okay, negative 4 plus minus the square root of 4 squared, which is 16, minus 4 times a and c. Now a is 1, c is 4, therefore 1 times 4 is 4, so 4 times 4 is 16. So it actually all cancels out. And then we have 2 times 1. So it ends up being negative 4 over 2, which means that x equals negative 2. And the way we can then connect that to the x plus 2 up above is those brackets are always x minus a, x minus b. Therefore, if a equals negative 2 and b equals negative 2, then that ends up being x minus negative 2, x minus negative 2, which when you multiply a negative by a negative, you end up getting x plus 2 and x plus 2, which then becomes x plus 2 squared. On top of this, so not only does this help with factorizing, but it also means that we can skip the whole factorizing step and go straight to what is x equal to. This will only work if the quadratic equation is equal to 0, though. So we've got that x, in this case, is negative 2. So now let's go on to the next one. So we have x squared plus 9 equals 6x. Now at this point we don't have 0 on one side, so the first thought would be, oh nah, I can't actually I can't use the quadratic equation. However, this is where we go back to the rearranging again. So in this case, instead of getting like terms by themselves, we want 0 on one side because that's the condition required to use the quadratic formula. So we have x squared plus 9, and in order to get rid of that 6x on one side, we need to subtract 6x from both sides. So 6x minus 6x, which then ends up being, and I'm just going to put this in order. Generally, the order for an equation is you go with the highest power of x first and then go from there. So we get x squared minus 6x plus 9 equals 0. And again, we can either go for factorizing it just by ourselves. Like me, I've been doing this kind of factorizing for over a decade, and so to me I can just look at it straight away and go, okay, 9, the factors of 9 are 1, 3 and 9. What two numbers would add together to get 6? Negative 6, and that would be negative 3. So therefore I know for a fact that it's going to be x minus 3 all squared equals 0. And again, we can go through, we can check this. So we have x minus 3, equals 0. Then we have x minus 3 minus 3 bracket x minus 3 equals 0. So x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x, and negative 3 times negative 3, because it's two negatives multiplied, is plus 9, which then ends up being x squared minus 6x plus 9. But again, if you're not that familiar with all of this stuff, what you can do instead is you can then use the quadratic equation. So x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And in this case, a equals 1, b equals negative 6, c equals 9, and so we go negative b is going to be 6, plus minus the square root of 36, because negative 6 squared, any numbered squared will always be a positive, so we have 36 minus 4 times 1 times 9, and 4 times 9 is 36, all over 2 times 1, which is just 2, which means that we have 6 divided by 2, which is equal to 3. And so then, because we have the x minus a thing, x minus b, you then end up getting the x minus 3 squared, plus we have the value of x is equal to that. So the way that you can actually go from here to getting that answer is you go, okay, so x minus 3 equals 0. You can't do addition and subtraction at the moment because you've got multiplying happening. But what you can do is you can go x minus 3 divided by x minus 3 equals 0 divided by x minus 3. And 0 divided by anything is still going to be 0. So we end up cancelling one of these, like so. And then we end up getting x minus 3 equals 0, which then means that x equals, we'll go through the steps. So x minus 3 plus 3 equals 0 plus 3, and then we have x equals 3, and it all works out. So again, nice, straightforward stuff. It all works, it all functions, and as long as you take it step by step with whichever method you use, you'll be alright. So, let's have a look at this one. Now, at a first glance, some people would be like, oh, what is happening? No! Because we've now got a fraction. Algebraic fractions, they're not nice. Why would we ever do this? And so I'm going to show you a couple of ways you can do this one. Now this one's been designed to be reasonably easy. So if we factorize this one, we've got x squared minus 5x plus 6. Now you can factorize that top part without a problem, because the thing is, if you multiply both sides by x minus 3 just to get this by itself, that side will still be 0. So let's plug that into the quadratic formula. So x equals negative b plus minus square root of b squared minus 4ac all over 2a, and a equals 1, b equals negative 5, and c equals 6. So we have x equals 5 plus minus the square root of 25, and then we have 4 times 1, which is 4, times 6, which is 24. Yeah, 4 times 6 is 24, all over 2 times 1. So what we end up getting, now that plus minus, this is because of square roots and stuff, because as I said before, if you square a negative number, you're going to get a positive number, therefore any square root, you could have a positive or negative result. So we end up getting x is equal to 5 plus minus the square root of 1, and the square root of 1 is 1, divided by 2. So x equals 5 plus 1 over 2, or equals 5 minus 1 over 2. Now, as you can notice, we're already slightly different to our previous ones, because we've got two possible answers. So let's go through with those. So 5 plus 1 is 6 over 2, and 5 minus 1 is 4 all over 2. So therefore x is equal to 3, or x is equal to 2. Now if we then go back to the whole x minus a, x minus b, that ends up giving us x minus 3, x minus 2. And if we expand this out, we can then make sure that it is in fact the correct answer. So x minus 2 minus 3 x minus 2, that's going to be x squared minus 2x minus 3x plus 6, which ends up being x squared minus 5x plus 6, which is the same as what was on the top originally. So now if we go back to this equation and we use the factorized form, so in brackets, we've got x minus 3, x minus 2, all over x minus 3 equals 0. Now again, when you divide something by itself, it cancels out, so we can cancel both of those out, which then actually gives us something nice and easy, which is x minus 2 equals 0, which means that x equals 2, because we added 2 on both sides, thus getting that. Now, if this were more complicated, you could in fact do something a bit maybe fancier. I'm loath to say harder, because a lot of maths is actually just more and more basic steps all put together. As I always say to my students, maths is simply how our brains work. Learning maths is understanding how we actually make an order to the world. So what I'm going to show you now is called algebraic long division. So what you do is you put in the term that you're dividing by in here, so x minus 3, and you put in your algebraic expression, so x squared minus 5x plus 6. Now I'm a little bit rusty on this, so I may have to correct myself 1 or 2 times, but it should be alright. So what we end up having, so we figure out, okay, how do we get x minus 3 to subtract that x squared? And the easiest way is we multiply it all by x. And we have to do, whatever we do to one part of that x minus 3, we have to do to all of it. So we end up getting x squared minus 3x, and that's because x minus 3 all multiplied by x is equal to x squared minus 3x. Now all we have to do is then we subtract that from this, and we have to put up the factor that whatever we use to multiply, that gets put up here, up on the top, and this is where our result will come out. So we subtract this, so that gets cancelled and that gets cancelled, and then negative 5x minus negative 3x is going to be the same as adding 3x, is going to be 2x, and then we bring this down here to plus 6. So again, what do we need to multiply x minus 3 in order to get the 2x plus 6? And that's, we multiply it by 2. And it's going to be, it will be slightly different. And that's fine. Actually, wait, yeah, sorry, that's negative. So yeah, no, we multiply by negative 2, which then gives us negative 2x plus 6, because negative 3 times negative 2 is going to be positive. 2 times 3, 6. There we go. So then we have negative 2x plus 6. So that ends up being 0. But again, we put in this factor here. And then we've got that x minus 2, which we ended up getting over there. And thus, that system can be used for much more complicated stuff. So let's go to the last one that I've got prepared. Then I'll probably just sort of play around a little bit, do sort of different examples, work through them, and all of that. So here's a fun one. This is only actually it's basically the same as the last question, just a little bit different. Okay. And so, and actually, if I remember correctly, this one ends up, this equation does end up falling apart a bit, which is fine. Like when maths falls apart, that makes us realize, okay, maybe this equation didn't work. And that is a-okay. There are mathematical ways of representing even things that don't actually work, but we'll leave those for now. Actually, I'm going to change this ever so slightly, just so that it does end up working. There we go. That one number will actually make this work. So, on the top, we have that x squared plus 7x plus 6. And we can factorize that down because the factorized form is the exact same as if it weren't factorized. And so again, we can quadratic equation it. Yes, we don't have that equal to 0 there, but for the purpose of factorizing, we can use the quadratic equation. The only thing the 0 is required for is figuring out what x is equal to. So in this case, we'll be getting the a and the b, not what x is equal to. So we have x equals b squared minus plus minus the square root, negative b plus minus the square root of b squared minus 4ac all over 2a. And we've got a equals 1, b equals 7, and c equals 6. So we have negative b, so negative 7 plus minus the square root of, now 7 squared is 49. 49 minus, now 4 times 6 is 24, so 24 all over 2a, just 2 by itself because a is 1. So then we end up getting negative 7 plus minus the square root of 25, because 49 minus 24 is 25, because 49 is 1 less than 50, and 50 is 2 times 25, 24 is 1 less than 25, so on and so forth. And then we have that over 2, which equals negative 7 plus minus 5 over 2, which is going to be negative 2 over 2, or equal to negative 12 over 2, which is equal to negative 1, or equal to negative 6, which means that when we factorize this through, we end up getting x plus 1, x plus 6, all over 2x plus 3 equals x plus 6. Now, at this point, some of you may still be thinking, what is happening? And don't worry, it's not too bad from here. So we have x plus 1 and x plus 6, and we want to get rid of this fraction for now, at the very least, just to have a go at getting rid of the fraction. So there are two ways we can go from here. So if we multiply both sides by that 2x plus 3, it'll cancel out the one on the bottom, and it'll bring it over to the other side. So we end up getting x plus 6 and 2x plus 3. Now, as I said, there are two ways of solving this. The way I personally prefer is we can actually cancel out the x plus 6's on both sides, because we just, on both sides, divide by x plus 6, and that ends up getting us x plus 1 equals 2x plus 3. And yeah, given earlier on if you have the same number of x's on both sides, it all falls apart. That's why I added the 2x. So now we rearrange. So we want to get the numbers on the right hand side. So we subtract 1 on both sides, so we end up getting 2x plus 2. And then we want to move the x's over to the other side, so we subtract 2x. Now 1 minus 2 is negative 1, so we end up getting negative x equals 2, which means that x is equal to negative 2. So that's one way of doing it. That's the way I personally prefer. It's a little bit easier. The other way we could do it is we could have actually expanded out each of these, then simplified to get a single quadratic equation, which I'll do now. So we defactorize that top part. We end up getting what we had at first, x squared plus 7x plus 6 equals, and now we need to spread out this other side. So we have x bracket 2x plus 3 bracket plus 6 bracket 2x plus 3 bracket, and that ends up being 2x squared plus 3x plus 12x plus 18, which ends up equaling 2x squared plus 15x plus 18. So rather a little bit messier, one of the reasons I prefer the other option. And then we want to just subtract one from the other. So because this has the higher x value, I'm going to subtract the other side from it. So we end up then getting, and I'm going to skip all of the working here because we have covered the working earlier on. So 2x minus the x squared is going to be x squared, and then 15x minus 7x is going to be 8x, and 18 minus 6 is going to be 12. Now for factorizing this, we could use the quadratic formula, but I can already see that there's a group of factors of 12 which added together equal 8, which in this case it's going to be 2 and 6, because 2 plus 6 equals 8 and 2 times 6 equals 12. Therefore we're going to have 0 is equal to x plus 6 x plus 2, which means, and in this case we end up getting, so we end up actually getting two possible answers for what x could be, purely because it's a quadratic. With a quadratic you have two answers, whereas with linear you'll have one answer. Sometimes with a quadratic you can have one answer, but generally speaking up to two answers. However high the power is however many answers you can possibly get, and so we end up getting x plus 6 equals 0, or x plus 2 equals 0, and this is because in one case we've divided, so in this case with x plus 6 we've divided both sides by x plus 2, but 0 divided by anything is still 0. And then we have x plus 2, in which case we've divided both sides by x plus 6. Lots of numbers and letters and all of that. Hopefully it's all making a bit of sense. So then we end up getting x equals negative 6, or x equals negative 2. Now that negative 2, that is one of the values we did get, and the reason why with the linear one we lost that that x minus 6 answer is because we got rid of that x plus 6 system. By getting rid of that, that meant we got rid of that minus 6 answer. So technically, if you wanted to be more correct, you would go with that longer option with the greater number of potential answers. So if we sort of recap, so we started with x equals x, and we understood, and getting that understanding of as long as you do the same thing on both sides of the equation, you're all good. Then we moved on to something a little bit fancier. However, we found that if you have the same number of x's on both sides, they're going to cancel out, and quite possibly your equation's going to fall apart. Then we moved into a system where you had two linear ones which all worked, and again we did the same things to both sides to get to a point where we had the like terms on either side of the equation. Then we moved into a quadratic. We looked at the quadratic formula, we factorized using the quadratic formula, and we also solved using the quadratic formula. We then had a look at what at first glance didn't look like a quadratic equation, but once it was rearranged and we had 0 on one side, we found it was a quadratic equation, and then again we're able to solve using the quadratic formula. We then looked at a quadratic with a quadratic on a fraction. However, once it was factorized, one of the factors cancelled out with the bottom of the fraction, and then it became quite simple. And then finally, we looked at one that at first glance looks much more complicated, but again was the same thing. We did have to think about various different steps, all put together, but in the end, all it was quadratic equation to factorize, then looking at what that result gave us, we could either expand it out and get two quadratics, which we can then simplify into one and then get the answer for, or we could have cancelled out common factors, lost one of the potential answers, but that's all right, and then we just had linear equations. So all in all, it's all just sort of those basic things over and over again. And we'll leave things like logarithms and exponentials and stuff for now, just because it gets a little bit messy. Let's go with just some random numbers. I have genuinely not actually thought about these. And I know that they're not going to factorize nicely. But that will be that equals 7x minus 2 equals 3x plus 5. So I'm going to go through and I'm going to solve this. Now we may end up having imaginary numbers, and if we do I'll cover that, but I'll basically go through it in a little bit faster than last time, but using again the same steps as the last question we had. And again, we could have actually, with the last one, we could have used algebraic long division, and it would have been interesting to have seen how that turned out actually. And we might use it. We might even try it in this case actually. Yeah, why not? Let's try some, because I don't think this is going to end pretty anyway. We will try some algebraic long division. 2x squared plus 3x minus 7. So what will we have to multiply this by? Oof, this is going to be a fun one. So 7x minus 2 multiplied by what gives us that 2x squared for the 7x part. Well, we have to halve it. No, we have to multiply it by 2/7 and x. So 2x over 7. So that's the first factor. Oh, I don't think I'm going to actually use my answer from this because it is going to be horrible. So 2x squared, and then negative 2 times all of that becomes 4x over 7. So plus 4x over 7. So 3 is equal to 21 over 7, because 21 is 3 times 7. So that means that we end up getting so 21 minus 4 is 17 over 7x. We bring that down to be 7 minus 7. Oh, this is horrible. And how do we get 17 over 7x with 7x? So 7x, so we have to actually divide by 7 squared, 49, and multiply by 17. So we end up getting 17x over 7 minus, so 17 times negative 2 is 34 over 49. Oof, as I said, not pretty. And then 7 in 49ths is 7 times 49, which is 7 cubed, which we're going to do a bit of long multiplication for this. 7 times 9 is 63. So, 3 and carry the 6. And 7 times 4 is 24. No, 28. Yeah, 28, but plus the 6 brings it to 34, so 343. Oof. So 7 is equal to 343 49ths. And that minus 34, so 343 minus 34, that ends up becoming 3, that becomes 13, so that becomes 9, that becomes 0, that becomes 3. So we end up getting minus, so that ends up being negative 309 49ths, and because that's not 0, we end up getting a remainder. Oof. That's fun. So plus 17 49ths, and so the remainder is going to be this negative 309 over 49 divided by that fraction there, which when you divide a fraction by something, that's the same as multiplying the bottom by it, so you end up getting 309 over 49 7x minus 2, which is absolutely horrific, which I'm not going to do. So I'm not going to use that because the final value is frankly horrendous. So we're going to get rid of that. And we are instead going to try and factorize the top. Yeah. Actually, no, we don't even need to factorize the top. Instead, we will multiply by what's on the bottom. So we have 2x squared plus 3x minus 7 equals 3x plus 5, bracket 7x minus 2. And so that's going to have to be expanded out. So 3 times 7 is 21x squared. We have 3 times 2, which is 6, and 7 times 5, which is 35. 35 plus 6 is 41, plus 41x. And, oh, no, because that's a negative, sorry. So, sorry, 3x, that's negative 6x. And then positive 35, so minus the 6, that becomes 29, so plus 29x, and then minus 10, and so then we simplify that through, so 2x squared plus 3x minus 7, we simplify that through by, we'll subtract this side from the other side. So we end up getting 0 is equal to, so 21 minus 2 is 19x squared, 29 minus 3 is 26, plus 26x, and negative 10 minus negative 7 is negative 3. So horrible, horrible system, but we can use the quadratic formula. So A is 19, B is 26, C is negative 3, which means x equals, oh, this is going to be horrific, 26 squared, negative 26 plus minus the square root of 26 squared minus 4 bracket 19 times negative 3. Okay, at least it won't be an imaginary number, which is nice. 2 times 19, negative 26 plus minus, so 26 squared is going to be 6, carry the 3 times 2, 6 times 2, sorry, is 12, but we carry the 3, so we have that. 2 times 6 is 120, so we carry the 1, so 2, and then 2 times 2 is 4, but we carry the 1, so we have the 5, so we end up getting 6, 7, 6, there we are. So we have 6, 7, 6, and then so negative 4 times negative 3 is 12, so we end up getting 19 times 12. 2 times 9 is 18, carry the 1, 2 times 1 is 2, but add the 1 because of that. We have 0, 1 times 9 is 9, 1 times 1 is 1, so we end up getting 1, nope, sorry, this is why I usually go from the 1s first. So 8, 2, carry the 1, 2, so 2 to 8, so plus 2 to 8, all over 2 times 19, which is going to be 38. 38. As I said, not pretty numbers, but I'm just going to sort of crank through this one and then we'll be done. So negative 26 plus minus, so 6, 7, 6 plus 2 to 8 is 4, carry the 1. My handwriting is just going to get messier and messier, by the way. 1, 9, 904, so the square root of 904 over 38, square root of 904, I mean the square root of 900 is 30. Yeah. So I'm going to approximate here because frankly with the rounding it's going to round to 30 anyway. Minus 26 plus minus 30 over 38. So realistically there's going to be a whole bunch of decimal places after that 30, but it's mostly going to be zeros for quite a while because of how close it is. Because what, 31 squared? 1 times 1 is 1, 1 times 3 is 3, 0, 3 times 1 is 3, 3 times 3 is 9, so 961. So the next closest square number is 961, which is quite far away, so we can round it to 30. So we end up getting x equals, so negative 26 plus, so negative 26 plus 30 over 38, or x equals negative 26 minus 30 over 38. I'm just going to move this up a little bit so that I have more room. Sorry, bit of a lag there. There we are. So that means that x equals positive 4, sorry. 4 over 38, which we can simplify further, or x equals negative 56 over 38, which again we can simplify that one. So this one ends up being 2 over 19, and then this one ends up being negative, so divide by 2, that's going to be 28, negative 28 over 19. And those are the two possible values for x for this one. So we rearranged, we solved, we did all of that stuff. I even started trying something out that didn't actually work out, but it was all just using those tricks from the beginning. So there's a rule of rearranging, rearranging, do same both sides. Then we have like quadratic formula, quad formula, and algebraic long division. We had factorizing. And yeah, like I pretty much just used those tricks this whole time. So keep them in mind. If there are any questions, as shown in a previous video, in the last one, the one that used Hearthstone for probability, I do have a Discord that's set up for this. This is for literally anyone who's interested, if you want to ask questions, if you want to suggest things, if you want to help other people out. You're free to join in and do all of that kind of stuff. But for now, I will leave it at that. And yeah, everyone stay safe out there, especially given the moment. And have a good afternoon, morning, evening, wherever you are. Yeah, bye.